In this video, we are going to delve into a fascinating yet potentially dangerous topic. Can geoengineering cool the planet? We'll explore the science, the risks, and the ethical dilemmas surrounding these radical climate interventions. The Earth is heating up at an alarming rate, with record temperatures becoming the new normal. And despite our best efforts, traditional climate solutions like renewable energy just aren't enough to curb the worst effects quickly enough. So now, facing a planetary emergency, scientists are turning to bold and often controversial geoengineering ideas. These are technologies and strategies that could literally change the fate of our planet, for better or for worse. But here's the real question that we need to address. Can we actually cool the Earth without causing unintended consequences or even outright climate chaos? Let's start with solar reflection, one of the most discussed geoengineering approaches. Imagine spraying tiny reflective particles, like aerosols, into the upper atmosphere, the stratosphere. The goal is to bounce a small percentage of sunlight back into space, reducing the amount of solar radiation that reaches the Earth's surface. It sounds wild, almost like something out of a science fiction movie, but it's inspired by natural events like large volcanic eruptions that have historically cooled the globe by injecting ash and aerosols into the atmosphere. The catch: mess with sunlight, and you might inadvertently mess with rainfall patterns, impacting crops, or even spark international political conflicts over who controls the climate. Next up is cloud seeding, another controversial technique. By adding certain chemicals, such as silver iodide, to clouds, we might be able to make them brighter, whiter, and therefore more reflective, bouncing more sunlight back into space. The hope? More reflective clouds, less heat absorbed by the Earth. But we're essentially playing with the world's delicate water cycle, a complex and interconnected system that we still barely understand. What if it works too well in one area and inadvertently triggers devastating drought conditions somewhere else, far away? And then there's carbon scrubbing, a more direct approach to tackling climate change. This involves using specialized machines that suck CO2 directly out of the air, like giant air purifiers for the planet. It sounds like something straight out of a science fiction movie, a futuristic solution to a global crisis. But the technology is real, and it's already being implemented in a few pilot projects around the world. The challenge, however, is scale. To make a real dent in atmospheric CO2 levels, we'd need to deploy thousands, perhaps even millions of these machines, and currently they guzzle a significant amount of energy to operate. Here's the fundamental dilemma we face. Geoengineering has the potential to save millions of lives, but it also carries the risk of unleashing unintended side effects and unpredictable results that could be catastrophic. So who gets to decide if we gamble with the planet's thermostat, and what criteria should they use? And what happens if a single nation, driven by its own interests, decides to act alone without international consensus? Geoengineering represents science at its boldest, its most ambitious, and arguably its riskiest. The stakes in this high-stakes gamble, nothing less than our home itself. If you found this exploration of geoengineering thought-provoking, tap that like button and hit subscribe so you don't miss our next deep dive into the future of our planet.